All right. So, yeah, as Christian mentioned, I'm going to be talking about challenges and opportunities in developing biochar-based functional materials. So, a little bit into that question that came up in the chat around new applications for biochar beyond concrete and agriculture. Um, and this is really based on our experience as a company developing a carbon negative expanded foam material that is based out of biochar. So I'll give a little bit of background first, and these are much less academically derived insights than what Thomas was presenting, much more about our own personal experience in developing technologies in this space and trying to bring them to market. So just for background, our company started as a spin out from Imperial College London and the Royal College of Art. We were graduate students working in a sort of double master's program, dually enrolled, called Innovation Design Engineering. Um, and we've been operating the company as a business since March 2023. So it's still a very new business springing out of that academic research that we were doing. So the team is myself, and I have two other co-founders. We have a variety of different backgrounds. And we took a very design-led as well as engineering perspective in the development of this product. So we were working with the chemical engineering department, conducting pyrolysis and hydrothermal carbonization of different materials, developing different ways of processing them into composites of different types, primarily different types of foams, and then characterizing those with the civil engineering department at Imperial. The pictures are intentionally a little bit goofy because part of this process for us was ensuring that development was made using um, very commonly available equipment and scalable technologies that could be adapted from other industries that exist already, so that when we did get something to work, we could then have a nice pathway to scale this. Um, at the end of that process, we were able to characterize the resulting material, which is now called carbon cell, and get a pretty good performance out of it. And that's where the sort of company side of the operations began, and the academic part of it sort of stopped for now. This is what it looks like. Better than many explanations I can give is the video of how it works in action. The foam is low cost, it's low carbon because of the biochar, and it's a rigid expanded foam. I'll talk about the applications we're looking at, but we did initial characterization for thermal insulation values, compressive strength and tensile strength, and looking at different properties such as acoustic performance and other various factors. We filed a patent this past February for the material and the process that we do, and we've been taking it on the roadshow since then. So what do we do with biochar? We take biochar from a variety of different feedstocks and sources, and we grind it down to produce pellets. And the reason why pellets is not because the material can't exist in any other form. It in fact can be manufactured in many different ways, but pellets are the way that the plastics industry consumes their own feedstock. So with these pellets, we can then apply heat, and the pellets can be expanded in a fashion that's really similar to the way that plastic-based foams are made today. We've done a preliminary life cycle assessment to ensure that the operations we do in transforming the biochar don't really negate the inherent carbon value of the initial product. And we have still a neutral to negative product at estimated negative 0.622 kilograms of CO2e after doing all the operations needed to expand it. So where does this go? As a foam material, it's a really broad market. We're starting with packaging, really. It's a traditional sort of entry point for many new materials in the market because of the large demand for novelty, and also because of lower barriers to entry from regulation. From there, we're also looking at other markets such as insulative packaging, modeling and fabrication in film and TV, arts production, acoustic insulation, flotation, so marine foams, and then finally thermal insulation in the built environment. And here are a few pictures of some of the products. The material can be molded, it can be machined. So we're looking at post-processing as well as the sort of how it's made. And we've tested for a few different properties. I won't go into depth on these, but the interesting ones to call out are around moisture buffering, where the biochar offers a really excellent value for us, and on thermal conductivity, where we've been improving month over month since initial characterization. So why biochar? Why did we get interested in this space that you guys are all deeply involved in? For us, it was a bit of a personal connection and also a passion for the potential of the material. So Juan here on the left is our fourth co-founder, who unfortunately is no longer with the business for personal family reasons, but he's from Mexico. And in Mexico, there's a problem with the sargassum seaweed bloom. So initially, he started looking at ways of remediation in on the beaches to reduce the methane that's produced by this seaweed bloom and accumulation, and came across biochar as a really interesting technology for that purpose. And upon researching it more, we began to get really fascinated with its potential for scaling carbon removal and while having functional uses and positive other effects on the environment. So that's why we got interested in the material. We'd seen a variety of different applications, some of which have already come up in the chat already. So agriculture is the biggest one that everyone knows, but then concrete is very widely studied now and scaling up. Things like catalysts and filtration is another one. But we thought that can't be it. There's got to be many other uses for this material that can valorize it and support enhanced and expanded production. So we looked at foams. So why foams? First of all, it's a really big problem space. We see that around 10.6 million tons of EPS, which is expanded polystyrene, alone will be produced this year. It's a big market, so it's a huge $109.6 billion globally for these foam materials. In terms of their characteristics, uh, foam producers are already experimenting with integrating carbon into them to enhance the traditional plastics performance in terms of strength, lightweightness, and performance in terms of thermal capacity. So we thought, let's go one step beyond that and see if we can develop one based on biochar. And finally, they're under tremendous pressure to decarbonize. Available alternatives to these materials haven't really scaled yet, and the manufacturers are under pressure to find new materials to sub in for things that are being regulated out. So getting into the meat of the chat, I'll share some of our challenges that we've seen, and it's more to drive questions and discussions afterwards from everyone coming from different perspectives around how do we take this material biochar and how do we develop new applications for it that may go beyond what the industry today is oriented around. So the first one, which I think will not be surprising to anyone, and is something that Christian, his co-founders, are really working on at NCHAR, is helping with variability and sourcing. So for us, variability in material characterization is a really big bottleneck. We have experimentally tested over 25 different types of char to date, and the results can be highly variable. Some of them are non-fatal variations. Some of them are lead to critical failures in our technology. So of course, we know the input variations on feedstock type, processing time, processing technology, and processing temperature can affect all range of different values from pH to carbon content, water capacity, and that's not even considering things like trace heavy metal contamination and PAH. All of those factors contribute to differences in our output material, such as reactions with our binding agent, the viscosity and the rheology of the material, its heat absorption capacity, its electrical conductivity, the foam pore size, the density, thermal conductivity, moisture buffering, and the overall environmental footprint. So we end up with this very complex matrix of variables that we need to eventually control for in order to get consistent, scalable materials out of this raw input. So, and it's not common to us, I think, how to characterize efficiently. So you can run characterization on all of these. However, doing so as a private company can be very costly, and initially trying to understand exactly what to be measuring and what not to be measuring is also a question of efficiency and time. Secondarily, complex correlations exist between these at each stage of the processing that we do on the char, whether it's the particle size that we sieve and grind to different parameters that might change throughout the process of what we're adding to the material. To date, it's been really difficult to find correlations with things like regression analysis. AI and imaging are a really interesting area here where insights can be derived much more efficiently, and we're really curious about applications of that technology in eventually scaling up and solving this issue. Operationally, there's also a question around spot checking and controlling at scale. So beyond the initial understanding of the relationship, how do you implement really good QA strategies that are not too onerous in terms of cost and timing at scale? And I should say some of these things are not unique to us, but also evident in looking at concrete and other advanced materials. So the second area of challenges is around scale and supply chain. And this is more of a challenge as it comes to answering investor questions. And if you think about the broader market for these materials, part of the barrier to scale is around financing. And in order to secure financing, we need to be able to educate a lot of investors around the maturity of these supply chains, the future, and answer really valid questions they have in looking when looking at demand for materials in terms of total volume of biochar production versus total expected volume that we would need to produce at scale. The third one is around carbon markets. So inherently, we saw in Thomas's presentation around that 25% of the revenue there coming from carbon credits. And it seems that this is a driving expansion of supply, which is great. It's a key part of supplier business models. However, particularly when in sort of educating the wider market around biochar, there's still a lot of uncertainty about where those carbon markets will go and the regulations that are coming down the line that introduce just a degree of risk around what the economics are going to look like. And then finally, in this carbon sector, the certifications and methodologies that exist for agriculture and that have been developed for construction materials like cement are great, but it is a bit unclear to us how those certifications and methodologies can be expanded to cover new materials coming down the line. And I mean unclear in terms of who drives that research, academics or private business or collaborative consortiums. And then also what exactly needs to be studied and proven. And particularly for us, because we're dealing in sectors where the material has a very diverse end of life option and potentially a very long tail of where it ends up, there's a question of verification and understanding how do you underwrite the sort of lifetime of that carbon. And then finally, I think it's finally, I don't want to go on too long about all the challenges before getting the opportunities. Market education is another one. So we see a huge range of different levels of education about the topic. Obviously, everyone in this room is more engaged, but depending on who we talk to, it's difficult to know where to start. Do you start with the fundamentals, or do you really assume a certain level of understanding around the technology? And particularly, that may be alluding to different levels of perceptions, either derived from news articles or not a comprehensive understanding of biochar. that can skew investor perceptions. That extends to misunderstanding of life cycle assessments around production and things like the sort of heat cycling, questions like why biochar and why not just biomass? So what is the inherent value of pyrolyzing or processing these materials into pyrogenic carbon? And then maybe more interesting for construction and for us in insulation space is a lack of understanding about flammability, which is perhaps understandable considering the processes we're talking about. So onto the more positive side, opportunities, and ending on a good note. So I think we've found there is a hugely supportive network and highly engaged community in this space, and particularly in contrast to maybe the arms race that might be happening in other sectors developing advanced materials. We've found that groups like this and highly engaged experts and advocates have been really willing to help us educate ourselves around the market and share their experiences. We found that there's a very interesting and maybe unique long tail of both the cottage operators and tinkerers in this space, alongside really highly sophisticated. I see someone waving on there, Brian. Hello. Yeah, alongside highly sophisticated technologists and industrialists, and I think that is really exceptional when we think about particularly for us, distributed production and ultimately trying to get this into the hands of the most people possible so that it can have maximum impact. And then finally, we've been really encouraged. We have a fairly strong values ourselves. All of me, myself and my co-founders have sort of exited a previous career and are motivated by making an impact for sustainability. And we have no question really when we engage with biochar folks that they're motivated by the same things, which is really encouraging. Second interesting area for opportunities around new types of char that we're seeing. Maybe these are our producers, supply partners bringing to us, or academics sharing with us as production is scaling up, new feedstock opportunities are coming down the line that might be more interesting than what we've seen before, and particularly those that lend themselves to materials development as opposed to agricultural application. So those may be from waste streams and new and different waste streams that are just being tested in pyrolysis and valorized there, or things like food waste where there's a high salt content that could be potentially very interesting in terms of functional performance in our material. Particularly interesting is the built environment, maybe inspired by the success that the concrete and biochar collaborations have had, is interested in going beyond that and working in a circular way with building materials as an input to pyrolysis, and also working with insulation and building envelope specialists and architectural designers to develop other biochar derived materials like ours. So that's very exciting. And then technical advantages. So for us in working with this new material, while there's variability, there's also really interesting enhancements that it's given us. So the improved strength that we've seen in our material versus baseline, this ability to modulate the pore size of our foam by using different types and strategies with biochar. As I mentioned earlier, a great moisture buffering capacity, which is good when we are looking at building performance, particularly. And the full extent of these properties is still not fully known to us. So there may be more functional advantages we can get from using biochar that we haven't yet uncovered. And then interestingly, because there was getting more questions around heat cycling and location and setup of facilities, we've seen interest from our manufacturing partners, our downstream manufacturing partners who might be foam expanders. They're using a lot of heat in their process to co-locate biochar production facilities close to manufacturing and develop these sort of hubs where there can be on-site production of biochar and then conversion into new materials, which is a really exciting, maybe complex business model, but also something that could be really interesting in terms of energy and efficient usage of the resources that come out of these processes. So before I open for questions and also discussion, because this is more of a an autoethnographic sharing of opportunities and challenges. So we are currently funding. So we're doing pre-seed round right now. So anyone who has connections in that regard is always helpful to send our way. Open to new conversations. We're right now looking at scoping some collaborative research on that characterization element that I mentioned, and also the systems level operation, so valorization of new waste streams. We have a few upcoming potential grant projects on that, and are looking to bring on consortium partners and make new connections. And then functional testing. So we have a few more scheduled trials for construction materials testing this fall and into the winter. And then we'll be launching our first closed trial of the product for packaging and acoustics fairly soon. So if anyone is interested in applications and testing out the product and getting a few early samples, definitely contact me after this and we can have a separate chat. So um, with that, yeah, any questions? I can open up the maybe
Thank-
stop sharing my screen so I can see the chat as well.
So thank you very much, Liz. A great presentation and I think a very good or very interesting project with this expanding foam. I would have a first question that also touches on one that Moritz asked. So Moritz's question was, what's the price for a ton of biochar you would need to create a feasible business case for the cell foam?
Yeah, I mean, I think it's really dependent on some of the downstream operational costs of our expansion process. So the large majority of our costs are actually on the tooling and on the expansion, not on the raw material costs. So it has to do with the units that we're producing as much as the raw materials. But ideally, we would be targeting a price between 560 to £1,000 to be sort of efficiently performing at scale.
Which is, I think, the first time I ever heard someone with that high range of I'm fine with it.
I
So
mean, if it gets better, great, but that's what we
no,
can
that's good.
accept. Yeah.
And my follow-up question on that one was, so because your target market is packaging, so I guess you're already in talks with packaging manufacturers. Um, what is their view on your product, and are they interested in investing in this?
Yeah, so I had an image I was going to put in, but I ended up not. The biochar, sorry, the foam expanding manufacturers are very interested, and they've been perhaps surprisingly open to collaboration on this. We had one manufacturer offer up their facilities for us to use to a manufacturing trial for free before opening it up to maybe co-development down the road. They see the writing on the wall in terms of plastics and taxes coming, and so they're looking for avenues to have new materials to offer to their customers, and also because many of them need to reduce their own carbon footprint. They're interested in sort of the larger uh, business model behind biochar and what could you be doing to, I guess, overall meet their goals. So yeah, they've been really interested in it.
And they're willing to pay a premium, or they don't have to pay a premium because it's actually similarly priced, or
Yeah, exactly. It would be affordable enough for them to not have to pay a premium in the long run.
um, so a question from Mike. Hi Lee, is this a closed cell foam, and do you use a conventional blowing agent to create the expansion?
Yeah, great question. It's the shell of the molded object has a closed cell structure. However, if you cut it open, there will be open cells on the interior. So it really depends on the design and whether machining or molding is the process that we use. And then in terms of blowing agents, we don't use pentane gas or any of the current used plastic blowing agents. We use something less toxic.
I just want to say that would cut a bit into your storyline. Um, and the follow-up question, or not follow-up, previous question from Dan that builds up on that. If your biochar is ground to a powder, I presume its ability to filter air and water would be reduced. Have you thought about water filtration with your foams?
Yeah, interestingly, it's come up a couple of times. Because the binder that we're using currently degrades very quickly in water. It's not really the right application for us right now. However, air filtration's actually more interesting. Um, yeah.
Okay. Follow new question. Is the packaging be compostable?
Yeah, exactly. So the packaging vision for us is that it is hum compostable as well as compostable in anaerobic digestion and in vessel composting. The biochar in those cases would not necessarily be degrading any further than it would be in soil application, but the binder would degrade and it would sort of leave the biochar that would be suspended in it in that composting cycle.
Um, uh, Jairo Laura was asking, is there preferred biochar producing process for expanded foam applications?
Yeah, really good question. Right now, that's one of the challenges that we're seeing, which is defining exactly what factors in the char make for a good expanded foam precursor. And we've come up with a few hypotheses, but the interrelations between those are really complex. So still stay tuned.
So because I think you mentioned that you tested 25 biochars, how many would you say of these you could potentially use, and how many are completely useless?
Yeah, we've seen maybe like a 3 out of 5 success rate.
Okay.
And that's just anecdotally. So some of them, as I mentioned, are kind of on the borderline where it works but not as well. And then some have critical failure where it leads to an adverse reaction with the binder.
Okay, and these are industrial biochars.
Yeah, primarily. Although we have looked at some more, I guess, caught it like low-tech biochars experimentally as well.
Okay, no, very interesting. I mean, I know that some biochars foam when you produce them, but I don't know what you're doing, so I cannot comment on that. So
Yeah.
Frederick was asking, does your financial model work without grants?
Yeah, so we have grant support right now, which has been really helpful in the first year, because our process does need to be scaled up before we can really be a revenue generating business. We do need investment. But in the long run, it does not need heavy grant or government support to work.
I guess that's a good place to start. So Dan has another new application idea. Could the foam be inoculated with microbes and used as nourishing tree guards that degrade over time?
That I Let's have a chat afterwards. So horticultural applications for foam is a really interesting area that we haven't fully explored yet. We know that foams are used to protect seedlings and trees when they're in their early stages, and it's always been a hypothesis that the material could work really well in that, but we have not yet tested it. Anecdotally, I'm about to make some plant pots and see how it goes, but not yet sure on that.
I
But
mean,
great idea.
it's a great application. My colleague here at the UKBSC was working on biochain forestry, and these plastic guards are actually one of the main issues in forestry
Yeah.
because they fuck up the whole CO2 balance. And Hugh, another biochar expert, what is the peak temperature used during foaming? This feedback into the biochar properties pre-conversion.
Yeah, so in our process, the temperature is not particularly high. It's around 115, 120 degrees C, so we're not really getting that hot when we actually do the foaming.
And do you have a waste from your process?
There's steam generated. Let's see. I mean, we have sort of offcuts, I would call them. So things
Mhm.
that come out that don't get molded effectively or that are removed during machining. And effluent sort of water we used for washing things and
Okay, but
um
no nasty chemical waste.
no.
Great. That's maybe a more positive last question. So what is it that you would like to find in a producer coming to you? What's your perfect answer to this presentation?
I guess openness to collaborate and look at new I guess new characterization techniques, understanding more of those circular opportunities. So one of the interesting things that's come up with packaging customers is if there's a large customer that has access to biomass as part of their operations, let's say they're in the food and beverage space or maybe even an adjacent industry, could they be using and valorizing that waste? And we produce the char and then convert it into the packaging for that customer. So we're interested in producers that might be open to thinking about operational setups like that and yeah, new models, I guess.